Welcome to Study Loop.
So from the beginning, for this situation, we know that n1 is equal to 1.5, n2 is equal to 1, the distance to the object is 10 centimeters, p, and the distance to the image, I, is equal to negative 6 centimeters, and it's negative because it's on the same side as the object, p. So for part A, it says what is the index of refraction of the second medium, and that was given in the problem. We know that from the get-go, so we can just say simply that n2 is equal to 1.0. Part B wants to know what the distance to the object is. Well, that's pretty simple. We know that from the beginning. That's P, and it's equal to 10 centimeters. Part C wants us to figure out the radius of curvature. Well, to do that, we actually have to do some calculations. We're going to use the equation n1 over P plus n2 over I, distance to the image, is equal to n1 plus n2 over r. Or in other words, solving for r, we find that r is equal to n1 plus n2 divided by everything that was on the left side of the equation, which would be n1 over p plus n2 over r. And don't forget that n2 over I. And don't forget that I is negative. Plugging those values into this expression, we find that r is equal to 30 centimeters. Which we can box in as our solution for C. Part D asks for the distance to the image, and that was given as negative 6 centimeters, so I is equal to negative 6 centimeters. And then we're asked some conceptual questions for part E and part F. Part E wants to know if the image is virtual or real, and it also wants to know if the image is upright or inverted. So since I is negative and P is positive, the negative I indicates a virtual image. So we can say since I is negative, the image is virtual. Now to find if the image is real or upright, we need to look at the sign for the magnification. M is equal to minus I over P. So plugging in negative 6 centimeters for I and plugging in 10 centimeters for P, we find that the magnification is positive. Doesn't matter what the number is. All we need to know is that it's positive. And since the magnification is positive, the image is upright. Part F wants to know if the image that is formed is on the same side or the opposite side as the object that formed it. But since the image is virtual and these are lenses, it's on the same side. So since the image is virtual, same side. And we can box in same side as our solution to F.